Welcome everyone to today's session on risk evaluation of cloud services, differences between user perspectives and auditors' perspectives. So today we have our speaker is Mr. Sridhar Kalyan Sundaram. Welcome, Mr. Sridhar.
Thank you, sir.
So before I hand over the session to him, I'll just give a brief overview of our RMI Risk Management Association of India. So many of you might be member also, but still maybe for new people who have joined. So RMI is a global dedicated organization which is engaged in research and development in the area of risk management. It was founded in the year 1992, and since then, the basic idea of the association was to create a common platform for risk professionals and other stakeholders from the industry to have a common place where we can exchange news, views, and latest development in the area of risk management. So this association is administered by a governing council, supported by an advisory council and industry risk experts. So basically, our activities include online courses on risk management, organizing seminars, workshops, online webinars. So we also conduct offline training on risk management on different subjects for different companies. We conduct training in India, SAARC, Middle East. So we also publish a quarterly bulletin. So we have done a lot of webinars in the last few years, and we try to do at least one webinar a month. So we have a lot of partners associated with us from Nepal, Bangladesh. So recently we have signed a MOU with the institute in Nepal, and we have one MOU with IIRS from Saudi Arabia. So this is basically overview of our existing course we have on risk management. So this is again a very popular course, and people from more than 7 countries have enrolled in this course. In terms of upcoming courses, we already have few courses on risk management banking, then some few tailor-made courses on motor health insurance, and in next week we are launching a new course for learning generative AI in 6 hours. So I think since AI is the demand of the day, this course would be quite interesting, and followed by this introductory course, we will be launching an advanced course. So this is our group associates and patrons. So basically our delivery partner for online courses is smartonlinecourse.co.in. So before I hand over the session, I'll just give a brief introduction of Mr. Sridhar. So Mr. Sridhar Kalyan Sundaram, he is a MA in Economics, MBA, CIB, CISA, CRICC, and CRICP. So he has more than 40 years experience in the banking finance industry in India, Africa, and Middle East. He is an organizational risk and resilience management expert. He is also the member of advisory council of RMI, and currently he is a director on the board of Dhanlakshmi Bank and the chairman of the risk management committee of the board. So welcome, Mr. Sridhar.
Thank you.
So hand over the session to you, and at the end of the session we will have a question and answer session where you can put up any questions if you have. Over to Mr. Sridhar.
Thank you, sir, and good evening to all. Thank you, Dr. Rakesh Agarwal and RMA for this wonderful opportunity. Very recently, when Dr. Rakesh was calling and discussing about a webinar for December, one of my clients where I do a lot of risk management, consulting assignments, had a serious problem only on the particular topic we are going to discuss today. What is going to be the significant difference between how users of cloud services and the auditors of cloud services, what are the significant differences? And of course, there were issues behind that theme for the client, which we thought. Then I thought probably this is a question that is there in everybody's mind. particularly not just at the very top strategic level, but at the tactical and functional operational level between all of us. So when I suggested we adopt this as a topic, Dr. Rakesh felt also the same thing. And here we are. So over the next, 45, 75, 1.5 hours, we will be talking about three aspects. Basically, we'll try to understand what is that very significantly we all call cloud services. Most of us have been using cloud and cloud-related services, cloud-based services for almost for the past now 20 odd years. With or without a design, we are all using it. So what would be that can specifically, significantly point out to cloud? And therefore, as a user, particularly as a corporate user, what would be our perspectives, or what normally is the perspectives? And therefore, as auditors, why is even an audit required at all? There are 2 or 3 levels of audit that would be required during the course of that engagement as a journey. So we'll discuss that. With Dr. Rakesh's permission, one small correction in my introduction. I have ceased to be a director on the board of Dhanalakshmi Bank. I was till very recently. Probably it is my bad that I didn't update him. I was on the board of the bank till very recently. And when I was on the board of the bank, I was the risk management committee as chairman. But now I'm not on the board. But anyway, that it will still appear on my CV as, ex-member of the board. Yeah. Yeah. So that's about me. And, I mean, no, sir, it's my bad. I should have probably updated you. So with this, without much further ado, I will, go into what we need as a presentation to bring more of a focus. Normally, my presentation style is not to have verbose English on the slides, because all of us can read a slide, and where we have doubt, there are many ways to clarify the doubt. So you don't need really anybody, a medium like me, to do that. So what I do is the other way around. I use an infographic and then speak around using my experiences, using a little learning that I myself try to keep doing every day, and share that. And in that process, if I'm able to trigger some curiosity, further learning, ambitions, aspirations in a few of you, then I think the objective of RMAA in terms of propagating the knowledge, risk management knowledge, risk management consciousness, risk management thinking in most of us, because the younger generation now needs to carry this profession forward. As you can see, 40 years plus, we are probably closer to the exit route in this profession. So it is incumbent on you. So the basic objective, apart from sharing knowledge, apart from triggering a few thought process, is to further this process of creating further curiosity, further learning, thought processes in all of you. So that is the humble objective. With that, I will go into the presentation. We need the presentation to fix our thoughts on what we are discussing. That's all. So, sir, with your permission.
Yeah, please.
Yeah. So I hope everybody can see my screen. Yeah, anyone
we can see.
Yeah, thank you. So basically, what we are going to do is to have a sort of quick overview on what cloud services are. And as I have said, this is a recap. So some of the concepts could look, oh my God, this is so simple. And that is why it is very important to, recap on all those simple, little important things. So with that, we will move on to what we're going to discuss. What exactly is cloud computing itself? Cloud computing is, on a very basic level, it's not on your premises. One of the most rustic definitions of cloud has been, cloud is nothing but somebody else's computer, somebody else's hardware. That means it still has to have a hardware, somewhere at some point. Only difference here, in where you have an on-prem, difference system, where everything is visible to you, and therefore the management of that is possibly completely within your own, let's say, realm. Whereas in the cloud is exactly the opposite. If you still have the services running on your systems, but nothing is visible to you because they are not in front of you. That means you don't even know where it is. So therefore, what are the deployment? How is it deployed onto your system? Those deployment models, you can have public cloud, you can plug into it and play depending on what type of services you want to have. You can have a private cloud that is constructed only for you, your organization, your community, your whatever. You can have a hybrid of that where you move from your private to public, public to private, and so on. Most of us use something like that, right? So this is a model of deployment that defines whether it is a cloud or otherwise. Why is it important? Because the management perspectives, including right from design, deployment, and its management, the risk assessments and the risk mitigative controls, the control design, the deployment again, and its management, the entire life cycle is, you can say, almost completely a different book of instructions and it's so different when it comes to cloud. So we need to understand whether, first of all, it is cloud or not. So it goes by defining the deployment models. And who are the stakeholders? If you look at on-prem, where you own everything, you may have a lovely car, but you are not probably driving it. So what are the various stakeholders? You are the owner of the asset, but you may have a driver who makes it useful for you. So the driver is the guy who actually drives the vehicle, picks you up from your point of residence and back to your, to your work and to back or whatever. So there are different stakeholders with different responsibilities. Whereas in the cloud, it is exactly the other way. It is like your Ola. You don't own the asset, but you can use it by calling for the asset. And then, that itself, the service itself can be delivered by a different type of people. We'll look at it. So the stakeholders suddenly become different, though the service of getting picked up and getting dropped is exactly the same. So what are the various features that define that? One of the most important features, the difference, is the virtualization. When we say virtualization, what are we saying? We are virtualizing a hardware. That means it's an abstraction, whereas hardware is a very tangible, let's say, hard asset, a physical asset. Even a finance guy, counts the asset. That means very tangible. Whereas here, what we are doing, the tangible asset is virtualized to be able to provide services to different users, which gives a great feature called scalability. That means the asset is there. Asset has got a particular capacity, inbuilt capacity. There is a user that is using one part of the capacity. So the unused capacity can be quickly either scaled up for the user or distributed to different users. So therefore, if you can scale up, the opposite is also possible. Scale down. So you want something between 10 o'clock and 10:30. So from 10:31, I will be able to rent it out to somebody else. Whereas in your on-prem, it is there waiting for you to come to it and use it. And therefore, rest of it is possibly even tagged as idle resources. So you can see how the feature as a component or feature as a definition or definitive part of cloud goes to even defining how the asset is being put to use and how the asset is being, put to use in a productive manner. How is it productive for the user who is using it only for half an hour? He gets charged only for that half an hour. So those are features we will look at it. Delivery models, of course, one of the three most important delivery models most of us know are, IaaS, PaaS, and SaaS. IaaS, PaaS, and SaaS. This is what we normally, very let's say, crude manner call it. Most of us use SaaS. At least most of the time we use a SaaS service. Why? Because at some point in time, even though you're working from your own organizational platforms, even if it is hosted on the cloud, your own organizational platform, very unique, very private to you, your organization. Even if it is used, it's still going and talking to various applications for various requirements. For example, if you are, say, providing a particular service, and for the service, the end user is paying you through a card or a today, whatever, online payment mode, your systems are talking to the intermediate, banking system or settlement system or the payment gateways. So there is an interactive requirement at some point. At that point in time, it is using a service as a software as a service as a delivery mode. And for most of us in the production or even development stage, we use the platform services. In fact, these are, while they look like they are individual components and they are very, very, let's say, definable. That means you can easily say whether this is a software as a service or platform as a service or infrastructure as a service. They are actually not really, unique by themselves. That means at some point in time, there is always a requirement for an infrastructure for your software as a service to run upon. A platform that can support the software, a particular software or a particular version of the software, or for a particular interactive, requirement of this software. So if you look at what we have now spoken about in the last 5 minutes, defining cloud is a very, let's say, finite thing in terms of what the deployment models are, in terms of who the stakeholders with whom you're talking about. In fact, I don't know, most of you would even know who is your cloud service, the backbone communication service provider. You may not know. Why? It is not a problem at all if you don't know. But the question here is whether you know somebody who is actually providing you. Recently, there was this news item. I don't know how many of you were able to look at it and understand. Tata Communications hosts 30% of all the internet services connectivity throughout the world, throughout the globe, as we speak today. 30%, including submarine cables connecting various continents and so on and so forth. Right now, without this particular infrastructure, then nothing is what we use as an internet can actually work. And what we call as internet, if it doesn't work, there is no cloud. Simply the thing called cloud. Well, when I started getting into technology in the year 1990, I started my banking career in 1980. First 10 years was complete bullock. Then suddenly we moved on to a BMW called computerization. Now, till 2000, there was nothing called a cyber attack. Why? Because they were not interconnected. They were only unique, standalone, self-supporting, architecture. So if I wanted to connect my Chennai office to my Bombay office or Bombay zone, as we used to call it then in Standard Chartered Bank, we had to literally mail out or courier out the tapes for them to run it and integrate the various, data. So there could be only one type of attack. Somebody had to attack those tapes when they are in transit and then corrupt the data for the data to grow. There could be nothing called what we all today understand as cyber. So from that situation, when from 2000 onwards, today everything is interconnected. Today all of us are on this webinar, each of us sitting where we are, and we are discussing, and we are able to do this only because of the interconnectivity. 25 years back, this was unthinkable. Today we are, off-site. On-site is now becoming a rarity. So we have moved completely. The paradigm has shifted, as they say, if you want to use a cliche, right? So from that, it is possible only because of that network called the service provider, network. And 30% of that globally is controlled by one Indian company. I don't know how many of you are aware of this. Now, how did they build this sort of infrastructure and capability? They built a lot of it themselves, but they also built the scale by taking over smaller companies in smaller regions. For example, I myself worked for one such service provider in West of Africa, which in 2004 and 2005 connected almost the entire Western African coast, right from Morocco to, Guinea, Equatorial Guinea in the bend of the African bulge, as they call the Pacific bulge, right? So there was this small company. My company had a small company which laid all these submarine cables. Even that has got now taken over only because there is a benefit in globally managing it, standardization, transfer of data, and of course, the ability to absorb losses that could come from a low traffic area was not possible for a small company like that. So the infrastructure cost is very high, but operational revenue is very low. So obviously the mismatch is going to create all sorts of issues. So when a global company takes over, which is what Tata Communications seems to have done, they are today controlling 30% of the total, backbone network. Now, why is it very important? Now, imagine something were to happen to Tata Communications. 30% of the entire internet, as we know, will go down. Now, if 30% deficiency is available or 30% efficiency is not available for us, most of us will land up not performing or not completing or not being able to deliver what we promised to deliver. Because the computing, the transmission, and other things might come down very, very significantly. So therefore, we need to appreciate why cloud computing, what is the basic difference. We'll go on from here. Please note down any of the queries that may arise in your mind so that we can significantly use. There is a significant time allocation at the end of it. We can always go back to the slide. It's not as if you cannot interrupt me. The problem with interruption is what happens is we get stuck in one place, because by the time you finish your question, then your colleague, your friend may have another question. So we can take it back-ended if that is all right with all of you. So what are the essential characteristics of computing? These are the essential features. Now, what would be available on, what defines cloud? When you say cloud computing, what are those essential features? In fact, in a different training, I always tell them it is 3, 4, 5 definition. There are 3 types of deployment model. There are 3 types of service models, 4 types of deployment, and 5 essential characters. So we used to call it 3, 4, 5. In a very, for college students at the basic level of coming into computing, the MCA first year type of students. So we are now discussing the 5. We have discussed 3 and 4 already in the earlier slide. What are these 5? 5 essential characteristics are recognized throughout the world. Most literature that you might come across will talk about this. What are those? It should be on-demand self-service. If you go into Amazon, okay, your company goes and books Amazon sessions, has taken Amazon's, subscriptions, all that stuff. You suddenly think, okay, let me also do it. I want to start a small business on my own or some service on my own. It should be on demand. It should be available on demand, and it should be self-service. That means, what does it mean? In plain English, it means you should have a broadband connection and you should have a credit card. That means you should be able to demand that service, and it should be self-service. You can go, set up your own session that you want. Of course, subject to availability, subject to various conditions. That is a separate thing. So therefore, it should be on-demand self-service. It cannot be where somebody will provision it for you. I'm sorry. And it is always resource pooling. I gave you an example earlier. How do you think even cloud as an idea came into somebody? Cloud didn't simply pop out of the cloud. It didn't. We all invested. When I say we all, because I have worked though I called it BMW was still grounded on the ground. It was not, BMW was not cloud. What we did, we estimated our business requirements for the next, time horizon, maybe 1 year, maybe 3 years, and then said, okay, we want so much capacity to be able to provide service for the business development we want to do, and then build that capacity depending on organizational funding, right? Now, I am planning for 3 years. Let's say Standard Chartered Bank had deep pockets. They gave me a server that can serve my business requirements for the next 3 years. But the first year, I'm using probably 1/3 of it. So 2/3 of it is going to be idle. 2/3 of the server capacity, 2/3 of the server cost, 2/3 of the server resources are going to be idle for the next 2 years. So somebody thought, why can't I pool that resources? Sridhar wants only for 1/3, that is this year, but to the next 2 years, can I now use this for 2 other guys, 2 other requirements, 2 other services? So what is happening? optimization of resources came in. So resource pooling, essentially, if it can happen in a server in front of you, where you are able to partition it, you are able to assign it, you are able to manage it, we call it on-prem. Now imagine somebody sitting in Utah or Ohio or maybe even Singapore and doing it for you, right? So resource pooling, right, can happen not just in storage or processing. It can happen at the pipe level, at the bandwidth, at the transmission level. So what do you have to do? You have to understand what is the resource pooling that is happening. Not just as what is the resource requirement. I want 4 gigabytes transmission. Do you have it or not? This is the demand raised by the user. Great. So the service provider is going to be say, yes, between 10 and 10:30, this is what it will cost you. $1.52, something like that. Right? Now, it is not over. What is very important is this 4 gigabytes is a part of what is your total capacity. Now, why do you want to know that? Because you want to know whether he is giving you entire thing and therefore there will be a failure, or because you are only a part of it, so he has got 100 other fellows shouting at him in case of any problem, he'll be able to maintain it properly. So resource pooling, now we are coming to user perspectives. How is a user looking at resource pooling? At a very basic entry level, you may have no visibility into this thinking. But imagine you are sitting at the decision-making level, where you are even supposed to put up the paper for your top management or even the board approval. So how are you going to explain what resources you want if you don't understand what resource pooling is? So therefore, resource pooling for cloud computing is a very important box you'll have to tick. And of course, broad, network access. Now, broadband and uniband or single band. What is the difference? We need to go into a little bit of, most of us may or may not be technology guy. For example, I am not a technology guy. That means I don't come from an engineering background and all that. But it is essential for us to get into a little bit of technology, at least, in fact, a lot of technology, to understand what are we talking about in terms of ability of a broadband service that can help you, support you. That is what we said. When on-demand self-service, we said, you definitely need a broadband. So you should have one. They should be able to cater to one. They is being the service provider. So therefore, broadband network access. That is why as you go in your holiday, on a holiday to your village, in your native district, this happens to me. My native village is in Palakkad district in Kerala. Now, when we go there, Kerala is supposed to be one of the most literate, most connected state, and it's not a very big state compared to a UP or even Tamil Nadu from where I'm talking, and yet there is always a broadband, availability difference. Why is this happening? It is because the user dependent commercial value might be different in a little small village or something like that. So therefore, the service provider may or may not give you that sort of intense service provider. So therefore, there will be a deficiency in your service availability. Now, why should we understand this? Because the user wants, or user service providing or service requirements will need a consistent ability to support a variety of applications, variety of devices, variety of user requirements, and so on and so forth. And therefore, that broadband access is very important at both the service provider end and the service user end. Rapid elasticity. Elasticity, as all of us know, is ability to pull out and pull and come in. What can go back to its original shape. That means original shape of point of arrival of where you are not using anything. So you should be able to scale up and scale down. This is very important. Most of our resource management is always scaling up. If you don't use a resource, probably the resource is still there and it is idle capacity. So when you scale down, there is nothing idle because you already scaled down and it can be used for somebody else. And this should be in real-time basis. It can't be that you went and told somebody, please shut down my engine because I'm going to now stop working on this application. And he takes in his own schedule, maintenance schedule, he is scheduling it, in the first come first basis. So probably he has scheduled it 4 o'clock in the evening. So you made a request to scale down at 11 o'clock in the morning, but actual scaling down is happening at 11 o'clock. So your billing will be for the entire period till he does it. Whereas this should be the ability to do scale up and scale down should be immediate, a real-time basis. So that is a characteristic that defines cloud computing. And therefore, measured service. Measured service. When you're talking about service, we are talking about a bulk service. You take, again, let us use a car as an analogy. You take your car for a service, he will give you a menu of things that should be done on the car, and will give you a itemized, quotation for it. If the total is within your budget, you will say yes. Then you will make some adjustment saying, then you drop these two or add this thing, whatever you want to do, and you will pay. Now, whether he cleans the entire car, obviously all the exterior that is visible will be very clean, but the bottom of the car may be or may not be clean. You don't know. So it will not be measured for its entirety, but it will be measured in bulk. Whereas in computing, it can't be done like that. It should be to that nanosecond, not only to the nanosecond of usage of period of utilization, also type of utilization. You may be having a plain vanilla offer, or you may have a very special offer where data is also backed up, so on and so forth. All of us know there are any number of product differentiation that can happen today. And for each one of that, there could be a service billing that can happen. And each one of these are measured for what you have used and therefore can be itemized. So this is very, very useful from an accounting perspective, apart from the user perspective. So these are 5 basic characteristics that would define any cloud computing, whether you are using it for only 1 hour to do a game, you want to play a game, or actually develop a game that you are using a platform as a service to see whether you can develop a game that can tomorrow become a commercial product, and so on and so forth. It should have all the 5 characteristics. Otherwise, you're using on-prem services. Let's go forward. So what are the architecture elements? So how does the service provider, how does he put all of these things together to give it to you? There is a consumer, that is you. That is, you may be actually a consumer. Okay, let's say you're a bank. At the beginning of this, we were also, Dr. Rakesh was introducing me as a director of a bank. Let's take that bank, okay, without naming it, right? That bank uses cloud services, but also offers cloud services. To whom? To its own end users. To its own end users. So therefore, at many instances, you will have examples like this. You are primarily a cloud consumer as a consumer, but you are also a cloud service provider, CSP, because you are offering that particular service or particular application through a cloud. Of course, you are not the direct service provider. You are the guy who is the intermediate between the actual guy who is carrying it and you as a portal or as a service provider or the front end through which the unique set of service consumers will come and consume it. So therefore, somebody needs to audit all these things. Why do we need an audit? How many of you can associate the word assurance with the word audit? If not, please note down. Whenever you hear the word audit, please immediately bring to your mind the word assurance. Or the other way around. Can you assure me that this will work? If somebody asks you, even a plain text English conversation, let us say Dr. Agarwal is asking me, can you assure me that you will be available on 2nd of December for this? Can I announce the webinar? Let us say he asked me this question. What he is actually asking is, can you check your timetable and then ensure that you have blocked the time for me? So what am I to do? I have to go audit, that is verify whether I have blocked the time and all that. So an auditor or an audit as a process provides that very important thing of what? Assurance to all the stakeholders, not just the user. So an auditor's role is very important. So cloud, therefore here we are saying no visibility. We are saying so many characteristics will have to be made sure, ensured, otherwise it will not be cloud. Now who is going to assure us that this whole gamut of things is sticking without really being an entity, sticking together without really being a tangible entity? So therefore it is a third party, a neutral third party. Why neutral? Because he doesn't have any bias. A A neutral third party has no bias at all. He doesn't have a bias for the cloud service provider. He doesn't have a bias for the service. All he knows is if these 5 characteristics, these 3 deployment models, the 4 types of, service provider, all these boxes are ticked, he will say, yes, everything is all right or not. So therefore, there are audit systems that does cloud evaluation. That itself is a service. Only thing, it stays away from that. That means it is more external. If you do it internally, they are called internal auditors. They are very biased. Internal auditors have a very clear agenda. Clear agenda of saying, see if our systems are working. Whereas a cloud auditor is an external third party to say whether all stated systems are in place. So this is a very important thing. Why? Because all I have to do is not to worry about Amazon. I have to look at the cloud auditor who can nod, saying, yes, everything is all right, go ahead. So all the time, I'm referring to the auditor to ask me to help me take a decision. So from a user perspective, you see how important this part is. Because when the user takes a decision to engage with or increase the engagement with an existing cloud service provider or whatever, he always depends on that. There are any number of service certifications, self-certification, all the attestations. We'll come to that at a slightly later stage in our discussion. Then there are cloud brokers. Who is a broker? Broker is a guy who puts a owner of an asset with a user of an asset. Now there could be one user or 100 of users. You get down in Calcutta, you don't know, you're not booked your accommodation. You pick up one of the rigs. He will tell him, Baba, you take me to the closest good hotel. He will take one look at you and in his own assessment, he will assess, he looks like this and take you to an appropriate hotel. That fellow will tell you whether there is accommodation or not. You will check in, go do what you're doing and go on with your business. But the hotel considers this guy as the guy who bought him the client, this rig fellow. And he is the guy who knows who is the service provider, and he has picked up a user or a demand from a user and is able to meet it. Now, all he has done, let's say the hotel is a 20-room hotel. He has only booked one guy who came in from Howrah Express from Chennai, and landed there because he didn't have a booking, and he gave him an accommodation. Now, the hotel as an infrastructure has got utilized for 5% of its capacity. Otherwise, that would have gone unutilized. So it wouldn't have generated any revenue and all that. So a cloud broker is a very important element in, who aggregates all these demands and then appropriately takes them to the correct service provider. So cloud brokering is a very important element. Now, while we have used an analogy of a very visible, experiential learning that most of us would have, encountered in our lives, cloud broking is a service by itself. Cloud broking is a virtualization by itself. As you are going and inquiring about a particular service availability, the cloud broking systems pick up that inquiry of yours and then ask you whether are you looking for something like this. This happens to us when you go look for a hotel. If you look at on Make My Trip, what does he do? He gives you not just what you're looking for. If you're asking for a budget hotel, he gives you, a whole host of options. How is he able to do that? Why not he just give you one option? Saying, boss, you go book yourself into this room. This is budget. He is even asking you to define. Now, it is a virtual service. So, this is very important for aggregating demand and putting the demand into the proper slot, matching the service provider's capability to what is required for the user requirement. Now, user requirement is defined by whom? Not by the broker. You have to define it properly. If you don't, if you say, boss, give me the best hotel in Calcutta, and you go land up and tell the rig fellow, he will take you to Taj Bengal. And then you will find out you can't afford it. Right? So, user definitions will have to be correct. And then, if you are a regular guy, he will even know you, probably he'll give you, he will, pick you up. This happens to me when I go to Bombay on my own personal trips where I have, for my business trip. There is a particular taxi guy I, call. Now, what does he do? He picks me at the airport and takes me straight to, the YMCA in Bombay Center. because he knows that's where I will stay if when I come on. Otherwise, I don't even intimate him where my clients pick me up and drop me in the hotel and all. Why am I? What is happening here? He has got past history. He is able to use that data to know what these guys' requirements are, match the two, and then take you to the exact service provider. So look at the entire, let's say, value cycle time that is happening. The time is exact physical travel between the airport or the train. If I go with train, it's actually walking system. So a cloud broking system is a very important component. And of course, finally, the cloud carrier. The cloud carrier is the Tata Communication. How many of you know that you and I probably are talking over a Ericsson system right now? It could be. And in fact, when Amazon tells you, boss, don't worry, even if my Bombay region 1 is full, I will shift you to Singapore. Don't worry. How is he able to do that? Because he has tied up with all these service cloud carriers saying, in case my Bombay region, he has got thresholds. At 85%, 90%, he would already start moving sessions that are spilling over into the other service where the service has come down. It is always go east. Why? Because east is already shutting down. By the time Bombay or Bahrain starts, Perth is already shut down. Because the working hours would have come down and, the demand on the resources would be much less. And so on and so forth. So what we saw about resource pooling will be happening at a service provider level. So for that, cloud carrier becomes the most important part to be able to. He can switch over to Perth, but there is no bandwidth to transmit the entire traffic. Then he'll be in serious trouble. Right? It's like you're sitting in a beautiful Volvo bus, but you can't move to the airport because there is a traffic jam. Right? So that is what would happen if the cloud carrier is not one of the most important elements of this thing. If you want to look at it in a visual, this is how it looks like. So you are the cloud consumer, the guy at the left-hand top, the box. Then look at the auditor. Auditor does what all? He looks at security. He looks at privacy today, right? And performance, obviously. Whether the performance, stated performance can happen or not. So he constantly keeps checking it. And on the other side, on the right-hand side, very extreme, is your broker, intermediation, aggregation, arbitrage. What is arbitrage? Arbitrage is trying to leverage a service between two guys. He will tell the, Taj Bengal, boss, you better book this guy. Traffic is very poor today. He is willing to come and book you at $2,500. Don't worry about your going rate. Book this guy. At least you'll have some occupancy. And the other guy, he will say, you pay 2,500, I will get you Bengal type, Taj Bengal type of service. So a guy who is able to look at in basic terms, demand and supply depending on the particular unit of time of inquiry. That means at the point of demand, what are the various requirements that you have specified that can be, skillfully arbitrated to gain advantage to both the parties. So that service is also a part of cloud brokerage. So the cloud provider, what does he give you? He gives you service layers. Either he gives you infrastructure as a platform or as a software, then resource abstraction. We'll talk more about abstraction as we go down, and control layer. And of course, physical resource. As we said at the beginning, cloud is nothing but somebody else's computer. It could be next door, or it could be somewhere in the Utah or, Ohio, cloud hardware farm. Right? We don't know where it is. Or it could be anywhere in between. So what are the service management they do? They do business support. That means they can support the business related requirement of yours. Provisioning and configuration. How many of you have ever wondered when you buy a SIM card, you go into Airtel or Jio or anywhere, to the showroom, pick up a SIM card of your number, whatever numerology, whatever that derives your choice, and you plonk it into your handset, new handset that you bought with your latest salary, and then you find it is not working. Then you ask him, boss, why is it not on? I have paid the money. I taken a 3-year subscription, 1 year subscription, whatever. He will tell you, sir, a provision ko thoda time lagega. At least half an hour. Now, these days, half an hour. Those days, it will be 3 days. Now, what is this provisioning? Provisioning is ensuring that you or your requirement is made available, made recognizable at the other end. That is at the service provider end. Without provisioning, your number will never work. If your number that is allocated to you, which is linked to your SIM card, is just plonked into your phone, it doesn't go on immediately. Why? Because the Jio fellow or the Airtel fellow or anybody who manages their various provisioning, SS7 switch and other things, will have to provision it, configure it. In certain cases, they'll have to even configure certain security features. Now, portability and interoperability is where you can move from an Amazon to Microsoft to Google, wherever. Portability. Today, portability has already come in the Indian telecommunication system. It probably will come to the Indian banking system in the next 2 or 3 years. It was expected to come about 5 years back, but most banks have not worked in tandem. That means they have not worked consistently. Some of your bank accounts, will be 13 digits. Some of them will be 16 digits. Till all of these are standardized, interoperability or portability. That means you don't have to change your bank account number. You have to simply change your IFSC code for your various instructions. So it becomes very easy, seamless. You can change your bank, but your EMI will keep going from the same account. Only thing, the account has now shifted from your existing bank to a new bank. Now that is not possible. You'll have to go change the whole thing. So cloud service management, even as you're working on today, between the service providers, the three majors as we call, Azure, G-Cloud, Google, and Amazon, they have an interoperability system going on with them. Earlier, they were only pure competitors. They built walls that if you are with Azure, you can't go to the other guys, and so on and so forth. Now they understood that it's actually self-defeating. So they have removed those walls. They tell you, boss, don't worry, if I am full, I'll give you in Google. In fact, they have their BCP is already built only like that. That is why in Amazon is able to tell you, Mr. User, don't worry, you will never have a disruption. Now, never have a disruption is almost like a God. You're not God. But how is he able to achieve it? Because he has simply signed with the competition or what you think is competition. So portability is already happening, which is very good for you because your services are not getting interrupted. So this is the cloud service management the service provider is doing. Of course, it takes care of two important verticals. Security. Why? Where you have got 10 different children, you'll have to worry about idiosyncrasies of each child. You can't use one single rule. Why? Because each child has its own, rule or not following a rule. So security has to be very, very specific to the particular child or particular user. Whereas in your on-prem, it's very easy. All retail banking users, you will have to do only this. So one single management control will take care of requirement there. That cannot work in a cloud situation. Why? Because all retail banker users could be one fellow from Axis Bank, one fellow from, HDFC Bank, and so on and so forth, all using the retail banking application being provided by a cloud service provider, but each having their own unique features. So therefore, the security also would have to be properly or adequately and appropriately set to that. So that is the service they provide. And finally, now today we have privacy also, thanks to the DPDP Act, right? Privacy also. So what is critical information, sensitive information, who is a cloud service provider, who is a cloud service manager, who is the data manager, what is data, what is sensitive data, all those, various buckets will have to come into play. So all these are provided by the cloud provider. And the carrier is the guy on which all these guys run on. That is why that fellow is at the bottom. Most of us can't even see him. I don't know. I mean, I'm in Chennai. I don't know how many of you are from Chennai. I don't know even from people in Chennai, which is the landing point for the underground or submarine cable that runs from Chennai to Singapore for internet. How many of you know which is the landing point? You may not know. Not that it is a quiz question. I'm saying it is so invisible. I'm saying it is so invisible that we take it, yes, it is there somewhere. I know it is there somewhere. So since it is a submarine cable, it has to be somewhere in the seafront. That's all. We may probably use our intelligence to, arrive at that. But we may not know. But that has never prevented us, not knowing has never prevented us from using it. So it is an invisible but a necessary thing. Without that connection, you cannot transmit any data. Your service provider or layers of service provider can never transmit data that you intend sending to your servers or backup servers or processing stations in Singapore. So this is another infographic that I like very much. Of course, the pizza, security and all that, the cloud computing models. Traditional IT, all the red fellows, look at the guy in the middle. Everything was managed by you, right? Whereas in infrastructure, you still have to manage a lot of things. It is only in software as a solution, almost the entire thing is managed by the service provider. Why? Because even the software, he is hosting it. You only will have probably a browser-based, access to it on a controlled manner. Platform, yes, he may give you a particular platform for a particular requirement or a particular design, which will automatically, be under you for that period of, usage. There also he manages the runtime, and at the end of the runtime, he will simply shut down your platform if you are overusing it. So these are responsibilities that can be built into it. It's normally called the pizza diagram, right? But what is very important is the thing on the top, as you can see. What is the most important thing? Where do you really have greater interaction? It is always at the infrastructure level. That means even when you are operating software as a solution, a service offer that you're consuming, you'll have to remember that there is an infrastructure at the end of it. Whether it is being managed by you or by somebody else doesn't matter. You are in a train or a flight or a intercity bus from Delhi to Rohtak. You are obviously only a passenger. So you can say, driving the bus is not my responsibility. But if something happens to the driver or the bus, you will still be stranded. Just because you are not the driver doesn't mean you can keep traveling, irrespective of what is happening to these drivers. That means infrastructure is a very key component that enables the success of your SaaS session. So therefore, when you book a SaaS session, you would also want to know on what or which infrastructure he can give you the primary connection, and therefore, if the primary connection gets, let's say, full or fails or whatever disruption happens, where does it move? Similarly for platform, what happens when the platform gets over? How do I extend it? I am testing out something. I thought the test will take 2 hours. I booked a 2-hour session. Now runtime management, he will shut me down at the end of 2 hours, whereas I have not completed my testing. So what will happen? I'll have to rebook another session and start all over again. So how do I quickly, scale up and scale down? So for that, what are the various requirements? So it is not just what you want. It is also being able to understand what you want. How does it work? Where is it working? What are the various requirements that are? So these things then come into your consideration. Now, what will he tell you? First 2 hours will cost you only, $30 per hour or $3 per hour, whatever, right? But if you want extension, it will cost you $70. It is called preventive pricing. This sort of pricing is called preventive pricing, as most of us would know. Why? He is ensuring that you are not going into somebody else's booking time, because he has already sold. After your second hour is over, he has already sold it to somebody else. So that fellow is waiting on queue and he will be demanding, boss, what happened to my 2 hours? So therefore, he is pricing you at a level where you will pay for the damages he is going to pay for the other guy also. So therefore, these are perspectives that come into play from our knowledge of what is happening. You can simply say, boss, book a platform for our testing. Tomorrow I need to test this application before I roll it out into production. This is very nice. A user comes and tells the IT guys or the decision makers. Very nice, very brilliantly worded request. But do you know where to go request for that? Do you know how do you make the decision? Or look at it the other way. You are the auditor. How do you know the user asked for the right things, and therefore these considerations went into selection of that particular time slot or whatever? These are very important to understand. So let's move on. If you look at how the visibility is there, infrastructure, though that is the main thing, you have actually no visibility at all. Who has the most visibility? The architects. That means the guys who define, even in the user level, there are architects. They will say, boss, we want a minimum of these 4 things, right? So you can choose a 4-wheeler or a 3-wheeler or a 2-wheeler, right? Depending on what your budget is, what speed you want to reach, what service you want to deliver, and so on and so forth, right? Swiggy can use a 2-wheeler to drop the end product at your doorstep as the end user. But the production house will need a 40-ton truck to bring in his raw materials to be able to produce the goods which the Swiggy guy will do. So the architecture for the same product which Swiggy is doing the last mile delivery, which can be a 2-wheeler, limited service range, probably an EV scooter or something like that, which will go only up to 5 kilometers, can be organized. Whereas his raw material bulk that he purchases, will be a 40-ton truck. So that these end users. So the network architect defines at what stage what requirement is there. So least visibility will be there from the user when you look at the stack, the computing stack. Platform is slightly better. You have a greater level of visibility. Why? If you are a developer, you need a particular platform to develop it. That means which will support the type of languages, the type of design requirements, and so on and so forth. Most of you who have been in the IT world for a longish period will know that the same platform, it is not one single canvas on which you can paint everything. You need a different type of canvas if you're going to use oil paint. You different type of canvas if you're going to use a watercolor. In fact, you can't use a canvas, and so on and so forth. So depending on what is the type of development includes testing. You got somebody to develop, you got a TCS development team to develop a particular application for you. Now you want your users to test it. So you need to have the same exact production environment, to test what has been developed for you. You can't come and shut down your production and run it on your infrastructure. What will happen? There will be huge service delivery gap. So what you do, you go hire a particular platform which will mimic your environment and then test it on that. Now, application development testing are probably 90% of the platform as service user. These are not the only level for which it is used. Most common, let us say, most popular usages. There are any number of usages for a platform. Demos happen on platforms. You want one of us want to say, oh, Sridhar sir, I want to show one product demo, and he will probably book a platform that can support his IT and run the demo to me. So it can be for any amount of requirements. So they have a better visibility. Whereas software as a solution, because you are using the software, you are worried about almost every element. Your ability to look at the, entire connectivity, your ability to look at various security aspects, and so on and so forth. So the visibility is very, very large to the end user. So this is very important to know. Why is this important to know? Because according to visibility, the end user engagement is going to happen. Otherwise, he is going to simply execute what his role requirement is. You have a job card or a role execution, don't play, he will simply execute all those things. Whereas in a software service, if he is not able to get it, please retry, or there will always be a command. You try to, access something, it is not giving you access, it will only give you an alert saying probably your capital, your cap locks are engaged. Please disengage and try again. Or third time your password is not getting approved, you may get shut out. Please call admin, and so on and so forth. So the end user interaction there is very, very high. So there, the visibility to the end user is very high. Therefore, their ability to quickly react to situations will also have to be mapped, and what we call scenario development, and build the necessary controls for each of the scenarios that may actually transpire. So therefore, cloud computing stack, even at the user level, when we have cloud computing requirements, we keep this in mind so that we are able to ultimately, come out with our own controls that will appropriately manage our requirements. So how does the, OSI layer itself looks? Most of you know these 7 layers. This is not exactly a replication of that, but it is using that model. If you look at the applications, most of the applications run on your SaaS. Platforms run on platform as a service. Images are your operating system, Linux, Unix, Microsoft Windows. These are all most of your operating system, which becomes an image, where you consume what you know is interfaces, program interfaces. Application program interfaces, what allows you to use somebody else's application or use or is a bridge between your application and the other application to meaningfully transmit and exchange data. So therefore, when you have virtual computing environment, that is on a cloud-based thing, you have a cloud-based API, right? Hypervisors are what actually converts a physical machine or creates the virtualization in the physical machine. So I can install a hypervisor in my own laptop or desktop and create a cloud or cloud-friendly environment there. So my physical hardware will be very unique, very standalone. The hypervised or the hypervisor run situation, virtualized situation could be a cloud environment. So therefore, what are the type of hardware, servers and other networking equipment? You can virtualize almost every element, every physical element today can be virtualized. A firewall anyway is only a rule on a hardware. We all see firewall as a box, but that is to give it a tangible form. Otherwise, it is a rule. Even that rule can be virtualized. So every networking equipment, you can have a virtual VPN or eVPN today. VPN by itself is virtual private network, and you can have a eVPN, a cloud-based VPN, and so on and so forth. And therefore, data centers, in the earlier days, what will we do? We will partition a particular server and say this port or these functions will be available only for this sort of requirements. And therefore, because of the physical partitioning of the hardware, the other type of users can never use that resource, and so on and so forth. We can actually prevent usages by hardening of software. You can actually shut down a port or not make. I've seen very crude hardening in my audit days, earlier days, younger days, where people have actually shut down, cemented, actually not using cement as hardware ports, so that they can't insert this USBs and other network cabling and other things. Physically, they have shut it down. Why? Because the hardware came with those, original design came with those ports. So they didn't want that to be available to particular type of services. They simply cemented it up. So where you want segregation for various protection, availability, whatever, today they can be virtually shut down. So how does storage happen? Cloud is basically, that is why they put the icon cloud there. It is there somewhere up in the above. I always ask people why they did not put the globe, the bhumi, the earth, because you don't know where it is. What is the closest thing that you don't know where it is God. Whatever be religion. Can people say exactly where is it residing? We don't. I'm not going into religious talk. We don't know. So what we all do, whichever religion you go in the world, when they talk about God, they look where? They look upar. In most of the cases, literature also says uparwala. That is why cloud is also uparwala. That's what I always say. I'm telling you guys also. So the users use the service provider. What is the service provider guy doing? He uses the virtualization on physical machines to give you a server. So what happens to your data flow? Your data flow, when you send data up, right, or down, when you pull data down to, for various functions, it goes and it's finally residing in some physical machine. Earlier, in your on-prem, your data center was probably in Hyderabad or Jaipur or some dry area like that. You knew it went and landed up there. Your backup actually probably happened in your server room within your own machine, within your own floor or your own company, your own building, wherever it was. Today, it goes into the cloud through a virtualized environment into a physical machine somewhere, and the reverse also happens the same way. So when you look at a storage architecture, the storage architecture defines what is established or what is called a normal path. And therefore, there is always a alternate. Why? A normal path may or may not be available all the time. That is the basic, premise of a cloud itself. The very definition of cloud is that in case of any constraint, he will pool resources, resource pooling, and he'll be able to shift it instead of, route A, he will send it to route B to the physical machine or destination machine. Or even if the destination machine is something else, the addressing of it will be properly or logically maintained so that when you retrieve data, irrespective of where it is residing, it will be retrieving it in the proper form and fashion you require. One very good example is the telephone calls that we all make from our mobile, right? Mostly when we are at work, let's say your office is called, point O, and your home is point H, and your spouse is calling you, right? Now, logically, the shortest distance between H and O, the call is coming from H to O, right? The shortest distance, that means all the towers in between should be picking up the call signal from H and transmitting it to the receiving handset at O, isn't it? But that is not how it travels. The entire configuration is the quickest route, not the shortest route. That means it can go from H to O, not direct line. It can go in any zigzag line. Why? Because that is the fastest route. And how does it establish the fastest route? It establishes the fastest route based on availability. So such a configuration is very invisible. Such a configuration is managed by the service provider. Such a configuration doesn't matter to either the call originator or the call receiver. As long as you can identify the call either through your Truecaller or the voice recognition mechanism or simply from your contact database, you will be able to respond. If it is otherwise, you will want to know certain features before you respond to it, right? So how does the transmission actually happen is based on the configuration defined on their systems and not on your security requirements. So therefore, cloud storage architecture then becomes a very important perspective from the user. So in this, there is something called cloud bursting. Cloud bursting, means where the cloud service provider understands that there is a capacity issue in the area or the region defined for you, for your session. In cloud, when you use a particular usage, it is called a session, as most of us will already know. Have you, provisioned for your session? Have you demanded your session? And so on and so forth. Even when you go request, it's called a demand. So user makes a demand and service provider provisions for the demand. And then whether you use it or not, once it is provisioned, you will be billed for it. Why? Because he has set it aside for you. So what happens when what you are using, it is coming to 100% usage. So there is always an outage potential. So what he will do, he will push that service into extra capacity that you did not demand earlier. Why? Because he is monitoring your traffic. Now it looks very beautiful, isn't it? Somebody is monitoring what you're doing. But from a security perspective, it looks very dangerous. Why the hell are you monitoring what I'm doing? So you need to balance between a security risk versus a performance capability. Cloud bursting is always towards performance. It is like your load balancer. What does the load balancer do? Load balancer automatically shifts traffic into your redundancy that you have set up. So cloud bursting in the cloud is the load balancer that the cloud service provider has provided for your requirement. So therefore, on one way, from the performance side, it is a beautiful arrangement. From a security side, it could be a big if. And you need to have all the questions asked under the if. I will be okay with this if you give me this, if you assure me that there will be no security breaches, if you give me the entire environment as I had given you, as you have given me in the demand environment, the whole list of ifs will come around. Cloud busting, therefore, is a great thing to have, provided. Great thing to have, there is no period there. There is a comma, not even a semicolon. So therefore, what do? You want visibility. What is visibility? You want to know at what level he has set up the bursting. You want to know where his first level of drop is, what is called, where he is going to increase or push your services, at least the first level of drop, because he himself may not know. most of the time, this will bring in what we will see a little bit later, called jurisdictional issues. Particularly in India today, production data cannot be outside India. Okay, and live production data, live customer data cannot be stored outside India. This is what delayed our DPDP Act for the last 6 years. DPDP Act actually came into being, or should have come into being, in 2018. Sri Krishna Commission, Justice Sri Krishna Commission gave its recommendation in the year 2018. And it took us almost 6 years to bring it as an act, and the bill, it has come out, it will become an act now, it is already an act. Now, what is the problem? The problem is jurisdiction. So why it is happening? Because of cloud bursting, actually, storage and all that. And it is a great amount to automatically, as I said, performance management. Now, the orchestration means using all these resources, like using the various elements in a, orchestra, let's say Vienna Orchestra, Philadelphia Harmonic, and all that. How well individual pieces fall into their role, efficiency. And controls. What are controls? Controls are nothing but to mitigate the risk. When you hear the word control, simply there is a risk already. A control is applied on if you already identified the risk, it is an inherent risk or identified risk. So you apply a control. So these controls should be able to, properly work. That means the control efficiency should be very, very high. Why? Without interruption. That means seamlessly, right? Then it should be able to do peak level demand and non-peak level demand, and so on and so forth. All of these are where cloud bursting rules can be implemented according to the requirements of organization. If not, all of us, even if you are working from home, we log into our system, at 8 o'clock in the morning, there will be huge demand on the servers that are, controlling the access, because all of us are trying to log in at the same time, or more or less within a specific time band. So therefore, the capacity, the provisioning for capacity, the ability to look at correct thing, otherwise what will happen? Somebody will be given access and somebody will be denied access because he is waiting in the queue and he has been timed out. So therefore, all of this will have to be controlled. So what are the user perspectives? Whatever we have spoken about so far, you will see are only concerns. So today, whether to use a cloud or not is no longer the question. I still remember when I was the BCP manager for my bank way back in 1996, the DR part we pushed it to cloud and we had no idea what we were doing. That means we had a choice not doing it, but we wanted to do it because our head office in London said, go ahead and do it, right? But we had to learn way back. Another 3 years, it will become a 30-year-old story. Nobody will even listen to me. So whether to use cloud is no longer the story. So what are these stories? We will look at it. Security concern. I'll give you a small personal example. Most of you are very young. So go back to your teenage. What happened when you were a teenager, 12, 11, 12-year-old, 13-year-old, 14-year-old child? Your parent would have told you, come back at 7 o'clock. If you're a boy and you had a sister, a twin, let us say, they would have told that girl, you definitely will come back at 7 o'clock. Why? The perceived risk of a female child is very high in the parent's mind. So that asset will have a more definitive security concern. If the boy comes at 7:15, the mother will simply give him a, rundown. So immediate, action. He comes at 8:15, it will be escalated to the daddy, who will give you a rundown. Next day also you come at 8:15, probably you will get a thappat. That means the security concern, the rules that have been defined for the same asset for, whether it will be safe or not, will depend upon the asset value. So this is where your own children, where they go, you yourself want them to socialize, go outside, play, all these things, right? Where the asset has to be commercially engaged to produce a particular type of value that you want it to be deployed for. There these rules work. Now imagine, you don't even know where your son is going or daughter is going. That is now in cloud, right? So what are the security concerns? Child may or may not come back at all. How many stories we have heard, case studies? The child went out to play, we don't know what happened after that. I'm 66 now. Even today, it gives us a jerk when you read stories like that. Data breaches, data loss, malicious insiders. Malicious insider could be for various reasons. Motivations can completely change. The most loyal of the insider can, with just one single incident, become the most dangerous insider. That means at no point is given loyalty, a fixed value. So maliciousness of an insider could be as small as what happened in Cisco a couple of years back. That fellow, when he resigned on the last day of his work, he simply threw the switch in a, switch literally in the power switch of a major server. And about 1,400 clients lost all their data. On the last day of his leaving that company, that fellow simply went and switched off a server and went away. It took them 3 days to find it out, restore everything, and Cisco of all companies in the world, right? Insecure API. Somebody is saying use my. Why are we saying don't click on unknown links? Don't click on any link that you find malicious. Why? Because it is going and connecting you to something else that you don't know. So when you have no visibility on the interface or the application or the program that connects you to the application, if that is not secure at the other end, you are walking into an insecure thing. Shared responsibility. Where we say, boss, Dr. Rakesh and Mr. Sridhar will do it. No, not Dr. Rakesh is thinking Mr. Sridhar. So Dr. Rakesh, don't mistake me. I'm just using the others' names, I don't know. So he is thinking Sridhar will do. Sridhar is thinking, no, he is the boss, he will do it. Finally, nobody is doing it. Shared responsibility have a huge gaps between which responsibility can actually vanish. So it should be a defined responsibility. While you can define saying, both of you will do this, you will do that, together you will deliver this. That could be a shared delivery, not shared responsibility. So it should be very, very specific. Now in cloud, if you told Amazon, boss, tell me who will be your session manager on the 3rd of December morning session, he will look at you very funnily because he himself doesn't know. Because even if he gave you the Bombay session manager, Bombay region manager, he doesn't know whether your session will actually run on the Bombay resources or would have got pushed to Perth or Singapore. So very difficult. So therefore we come to regulatory compliance. Regulatory compliance, does it allow us to do things like this? Today regulators have understood. Initially they said no. They said, what do you mean he will push you to Perth or Singapore? That is not possible. He has to make sure that he gives you in Bombay. Then, they took a lot of trouble in explaining to various, regulatory bodies like RBI for banks, IRDA for insurance, and so on and so forth, SEBI for stock exchanges, so on and so forth, to make them understand why at a particular point, just infusing or investing in more, infrastructure is not possible, and so on and so forth. Then due diligence, insufficient due diligence. Do you know Sridhar? Yes, Dr. Rakesh has introduced. Now, this may be sufficient, may not be sufficient, depending on for what you do the due diligence for. If you are only going to do, listen to a webinar, yes, Dr. Rakesh of RMA has introduced Sridhar. So therefore, due diligence is okay. That might be for that purpose good. But you're going to open an account or issue a policy from your insurance company. Will that be enough? Certainly not. So therefore, depending on the purpose, objective, or the security required for the requirement. Denial of service. One of the biggest threat always in cloud is where the cloud servicer has been attacked. Service provider has been attacked. You are all right, but the service, it is like what happened in our COVID throughout the globe. All of us were all right, but none of us could move out. None of us, many of us, 99% of us survived. That's why we are all here, right? So sorry for the people who did not survive it. But then the question is, but what happened? There was a global denial of service. Then of course we had to look around, work around, and find out how well we can manage the situation. So that happened because of the denial of service. It can be a distributed denial of service. There are very many things. It is not a cloud security session for us to discuss that, but it is a security thing. Then improper cloud management. Citibank, all of us know. Some of us also know City Union Bank. Let us say the cloud service provider gives City Union Bank all the Citibank requirements. Okay. Now what will happen is when Citibank himself is trying to use it, he will not get that. Why? Because improper management of account. So that will give you an idea. This example, though this is a very crude example, does not happen that way. But anyway, it gives us an idea as to understand what we mean by improper cloud management. This is just one infographic for us to design. This is not an absolute or a total list of concerns. This is more of a discussion points. There are any number of other security concerns that can come in a cloud thing. Then why are we going to cloud? We will see. So for all these security concerns, are there no solutions at all? Oh my God, there are enough solutions. If you look at those 8 or 16, there can be easily put into 8 buckets of, how security can be provided. For example, when you look at authentication, cloud is always about access. In fact, any system is about access. You want to go into railway station, you want to go into the airport, you want to go into a bus station to catch your bus. Go back to our example, Delhi to Rohtak. Even if you are going to stop it somewhere en route and get in because your boarding point is different, he will still check, hey, are you Mr. Sridhar? And by very name, he knows that this is guy who is supposed to be waiting. What is happening here? He is actually authenticating the access of that particular passenger. He says, no, mera naam Sridhar nahi hai. He said, nahi, to tera ke liye nahi. Sridhar ke liye ruka kya. Bhag jo. So he will wait for the correct, access requirement. So you have multi-factor authorization, zero trust model. What is zero trust model? Is the exact opposite of trusted model. Earlier, if you get, sk at sc.com, it will trust that it is SK is Sridhar. There is another fellow called Sridhar Kalyanasundram. So it will be SK1. So it will trust, if the ID is given as SK1, it will say it is not the Sridhar Kalyanasundram in Bombay, it is the SK1 is the Sridhar Kalyanasundram in Dubai. So what is happening here in the system, and it is able to match to these resources because it trusts that anybody using that particular ID is actually the Sridhar Kalyanasundram. So now we are gone to saying, boss, zero trust. You prove that you are Sridhar Kalyanasundram, and you also prove that you are Sridhar Kalyanasundram from Bombay, not the other guy. So it is gone to zero trust model, as we call. That means it has eliminated all trust. That means what happened? We don't trust anybody. Is that a good thing? In information security, it is a very good thing. Probably in personal behavior, I don't know. That is more of an opinion. But in information security, today ZTA or ZTM, actually, ZTA is zero trust access. ZTM is the entire model, right? ZTM, one of my very good friends, Abbas Kudrati, he is an expert on that. You should listen to their webinars. You should listen to their YouTube channels. You will learn so much about why access can be controlled even in a diverse world as large as global cloud, right? So your IAM policy, identity and access management policy, and therefore conditional access. If you don't know which is Sridhar Kalyanasundram from Bombay or from Dubai, you will give him conditional. If you are Sridhar Kalyanasundram from Bombay, you can access only this application for this particular transaction for this period. So you already built in 3 different conditions. Conditional access. This is for authentication. What is authentication? Authentication is when access is required, it authorizes and authenticates. Authenticates and authorizes them. So access control, awareness training, IAM roles, classification and protection. Not all assets require the same protection. Your sales portal, you will say, boss, all of you please freely look at my sales portal. Why? You want people to look at your products, and you will even put a, counter there. You will say you are the millionth visitor. So congratulations, and you will send him a small gift or something like that. Now, that information need not be protected. So therefore, you should know what needs to be protected, and therefore, classification of data, classification of information, very, very important. Then protective technologies. You can have rules. How are you going to enforce the rules? What are the technology? How is the detection process going to happen? Right? Not only you say, yes, this guy is Sridhar from Bombay, you're also checking the IP address simultaneously, detection process. Is it anywhere near to any of the known IP processes from where. Now he is working from home, and his home, he has gone back to his village, native village, Thane, or outside of Thane, but the IP address says somewhere in Himachal Pradesh, and you want to know why. So therefore, the audit reports, that means all these will get logged and they have to be audited. So patch management, what is a patch? A patch is where a security gap is known and is covered up. That is why it is called a patch. How is known? It's known either through, where a breach has already happened by a hacker, or the development team themselves are testing out and they have found a weakness in their own system. So they are sending you a patch. Regular patch management. Particular audit, I always tell this story about 5-6 years back, just before the COVID. One of my junior boys, friend, he had become MD of a bank. He had a very particular persistent problem with his system. So he called me and said, boys, you come and check my system. I was talking to the CISO of that particular bank, and the lady, showed me her patch management process. I was amazed by what she told me, right? He had all the patches registered, very beautifully recorded. They had a pakka system. So I asked them, why are these two columns not even there? When was the patch deployed? And what were the experiences in the deployment of patches? Those two columns are not even available in the register. So she said, no, I don't deploy anything. So whatever patches were sent to her, she was, meticulously recording it and then filing it. So what do you think is happening to the system? Those breaches that the patches were supposed to cover now are even becoming beacons. They are no longer breaches. It is like Abel Mujemar. Somebody, a signal is, hung over that door, asking somebody to say, boss, come and attack me. So regular patch management is a very important, security thing. Then governance, putting all of these things together, risk management strategy. I can go reading through this. As I said, I don't like reading it. So when you look at implementation, you assess your security and then look at where your cloud services are going to land, both ingress and outgress. That means egress. That means where you send data out, where you receive data in. What are the landing zones? Then logging. Logging is a very important part of all transactions. As we speak now, our webinar is getting recorded for two purposes. One is for training purpose, for whoever wants to listen to it. What did that fellow say that day? One. Two, what exactly happened in that transaction? So from an investigative audit purpose, it's a very important part, logging, monitoring and logging. Logging, if you just design the log, is not enough. Somebody has to review the log. That is where governance comes. So continuous risk assessment will keep the cycle going, what we call, plan, act, check and do, PAC, the Deming cycle, quality control. And therefore your entire governance can be built. So defense in depth is always the most important part. When we say defense in depth, the most of English in IT actually are literal. But some English is exactly the opposite. When you use a word like defense in depth, it is exactly the same thing. It is not the opposite. It's only when you use words like redundancy, it is the other thing. If HR calls you redundant, that means you have lost your job. If IT calls you redundant, that means you are standing backup for somebody else. You have your job. So you can see, depending on who is calling you redundant, you can have your job or you have lost your job. So defense in depth is very important. And you look at the shared responsibility on the right-hand side. At the top, row is where cloud consumer, that is you and me, when we are consuming it, what we have to do. We have 7 steps to do, which starts with governance, then network security, data security, that is where your CASB broking, your data loss prevention mechanisms will kick in. IAM, we just spoke about it, application level security, then monitoring incident response. Anything is an incident. Anything that didn't happen is an incident. In banking, forged check is coming through clearing, right? And they return the check saying signature is forged. Now, they have prevented the loss, but that is an incident. So therefore, such incidences have to be found out. It's called a near miss. In aviation industry, if two planes are flying within 1,000 feet of each other in any direction, it is called a near miss incident. Just a small breeze can throw one aircraft into the other. And that's what happened about 16 years back in New Delhi between Uzbekistan and Saudi Arabian Airlines. And about 500 people lost their lives. Just a small breeze threw the two aircrafts together, one coming in and one going out. It happened over New Delhi, right? So, incident responses, how do you respond to them? Then endpoint security. What is endpoint? The machine in front of you, the device in front of you. What are the security required for that? Today, we have so many field level security apparatus. Biometric, eKYC has come. Biometrics can be captured with using a POS, point of service equipment. So how are those endpoint security or device level management are going to happen? All those are where have to be managed by the service provider. When you come down to cloud service provider, what is the third party assessment? Virtualization security. Your physical security itself is difficult. That you have to abstract. And then, build security. Then storage encryption. What is encryption? Changing plain text into ciphertext using a key. What is a key? It's a mathematical algorithm that converts plain text to ciphertext, which is indecipherable. It is meaningless. Ciphertext, what is encrypted text, is meaningless to anybody, even the user. The genuine user also cannot use. So the genuine user has to decipher an encrypted value to make it useful. So you have two ends to encryption. Encrypting data, production data into encrypted data, and decrypting encrypted data to bring it back into use, data in use. So therefore, management plane is the motherboard of your virtualization. Like you have your control motherboard, which controls all the other utilities in your hardware. Management plane is the virtualization motherboard. So all the authentication, everything can be built into that, or will anyway be dependent on the management plane. So if the management plane is compromised, your virtualization will collapse. So platform application, container services where you can have different type of applications running almost parallelly, because all its utilities can be built into that container without going and disturbing the other requirements. Incident response again. Then mobile device management. You may not be given access if the device changes. So in a telephone, what they do, earlier it was restricted to registered numbers. Today it is even restricted to the registered device. Okay. So all of these are to ensure that, their security concerns are alleviated, right? And in all of these things, what is the driving force? Driving force is multi-tenanted situation. Many tenants can be there in the same cloud service session. So if you look at any cloud service, I like this infographic, that is why I brought it to your notice. There are various layers. Endpoint layer is what is in front of us. Then there is a private network layer that connects you to the virtual data center, which takes you to the Cybersecurity. Of course, here he is providing you that service, but most of the service providers have their own provision. This is a commercial this is an infographic built by a particular vendor called Cyberspace. It's a very beautiful infographic that we can use. Let me tell you one thing. Always look at vendor, documents to understand anything. You want to know how your firewall will work? Please look at your vendor documentation. You want to know how to configure your firewall? Look at your vendor specification. They will be more specifically built for the particular purpose. And finally, how does it go to internet at large? So when you look at each one of these things, what are the various requirements under each of that? You can see at the private network layer, he is even talking about data loss prevention, secure socket layer, transport segment layer, sort of data protection. That means what level of encryption can be allowed or cannot be allowed, and so on and so forth. How is the entire transmission going to happen between two defined points? The ingress point and the egress point, and so on and so forth. So how is the user level decisions taken. If you look at on-premises, they are very, let's say heavy solutions. That is why it is tipping the scale the other side. Why? What are they heavy? You take each one of the components. The principal decisions, that means original decisions, are very, very high. That means you want to keep everything on premises, right? Then what is the interest cost of, maintaining everything? I started my career with State Bank of India. Till very recently, about 5 years back, not even 5 years back. Yeah, 5 years back, I think, 2018. They had their entire inventory of their physical assets, particularly land and building, in an application that is no longer supported anywhere in the world. What do we normally call this? Legacy system. Legacy system, the biggest problem is it may not have any vendor support. If there is a problem, you'll have to troubleshoot it yourself, all those things. And it may not be compatible with the other systems. So every time you'll have to download the data and then upload the data into your new systems for computation and all that. So in all that, operational risk, error of input, everything can happen. So therefore, when you have legacy systems, it becomes extremely difficult to manage it. Therefore, your operational cost will go up. Replacement cost. So that was the biggest driver. They were asking, when I asked them, boss, why have you not changed it to a newer system? The replacement cost is very, very high to translate all this. And therefore, the time and other things. Today, the cloud solution comes with a subscription cost. All of these are being taken care of by somebody. So he is able to manage even a legacy system. Why? Because he is able to use the same resource for about 20 other users. Whereas State Bank of India has to have one fellow to troubleshoot only for them. It could be very costly. So innovation is actually the actual leverage. You can go on improvising. You want to replicate something somebody has done very well, you can do it almost immediately. Whereas you had to build the capacity, test it out, and then deploy it. By the time the original fellow whom you're copying could have come out with another new thing, and so on and so forth. So these are the various elements that tip the decisions between the end user and the whether the user perspective or anything. So what is it? Is a cloud service, the cost is very beneficial? Yes, initially cloud is a better cost. Look at the graph at the bottom of this table that is in front of us. This is actually produced by Amazon. And Amazon himself tells you, normally the inflection point is over at third year. That means initially cloud will look very, very cost beneficial. Why? Because OPEX is only on what you use. CapEx is almost zero or very negligible. So it look all right. But the problem is, with that inflection point, cloud then becomes a run rate based requirement. Whereas on-prem, it could become a flat cost. This will become a flat cost at a higher point of arrival. So cloud eventually turns out to be, this is not my inference. I'm showing you an infographic developed by Amazon. The guy who is selling you the service is telling you, boss, after third year, I'm going to be costly. And that is the reality. He is not telling you something to ask you not to do it. He is asking you to come in with an informed basis. So you should be aware when you use cloud, yes, initially it will be very good, but as you progress down the curve, you will definitely at one point in time be paying more than what you will pay if you are managing it yourself. But therefore, what is the advantage? Advantage is what we saw earlier, the innovation capability. So there are any number of security frameworks for us to define and for us to follow. Your CAS benchmarks. Each one of these, AWS, Azure, Google Cloud, all of these guys follow the CAS benchmarks. Then the NIST, Cloud Security Framework, CSF, 800, 2207 is now becoming the global standard almost. Then you had the ubiquitous ISO 27001 and its various variants, 18, 17, and GDPR now for data. Then SOC 2 audit, which has become a very good attestation point. Then, of course, for card and card-related services, PCI DSS. So, therefore, when you want to implement a cloud security framework, you can look at how to create policies depending on which of the security frameworks will be suitable for your requirement. Then, of course, you can, what are the various security requirements based on the type of service you want to use. You can have, for example, a cloud security posture management, depending on which of the platforms you want to use, right? Then your workload performance platform. Then your, of course, access security brokerage. Then your cloud incident information entitled management. Then your security posture management. These are all various services that come with this. We are up to date with their CIEM. If somebody gives you that assurance, most likely that he has implemented the latest in the information entitlement management systems. So therefore, these are our key focus areas at a user level perspective. So it goes basically on the risk evaluation. So on risk evaluation, how does it happen? It happens on the total workload that you want to share in the cloud. And it has three key elements: people, data, and infrastructure. When you talk about people, you talk about access control, authentication, approval. When you talk about infra, you're talking about boundary, logical segmentation, hardening for you. Then when you're talking about data, we're talking about encryption, which means key. Key is particularly required according to your own requirement. So what are those keys that you will require, right? For your type of encryption, there, which are again dependent on your asset, your data, and data discovery. Data discovery is the ability to call and push data up and down. And logging and reporting, where you are able to design how data processing will happen. You can design the logging features also, but where data is being processed by the cloud service provider, of course, for under your instruction, are they even able to maintain the logging part of it that is very unique or specific to your performances, your production. So these are the information into which your, decision on how to decide on which, what are the risks with your cloud. So if you look at, let's say, your threat with your, shared technology, these 15 points are normally, actually OWASP has a top 10. There are any number of security issues that happens with open web application security processes. But these 15 points are normally considered the most common. And as you can see, most of this we have already spoken about, particularly on malicious insider test, threat, data loss. Okay, there are certain very technical, things like malware injection, where specifically somebody has, infected you with an intention to create a program that is not authorized, to do a particular function that will create damage to you or benefits to them or both, and so on and so forth. Then distribution of denial of service, DOS attack, denial of service, where your people go into your bank's application, they cannot go and activate it. Why? Because it is being denied as a service. That itself is a loss to you. So therefore, that can happen. So all of this, and each one of these have got technical definitions. It will take a long time to define that, because I do not know what is the common level of arrival for each one of you. So I'll have to start at the basic and start there, because I'll have to address the person who has the very, let's say, basic knowledge. That is the purpose of any webinar. Even the person with the basic knowledge should be able to carry away a little bit of benefit at the end of it, saying, oh, I did not know what it was so far, but I now understood it. So it will take a long time, but anyway, that is not the scope of our webinar today. So what are the various common risks?
Just to interrupt, Mr. Sridhar, if we can to move it little fast, maybe we can complete in next 10 minutes.
Yeah, we'll finish it in 10 minutes, Doctor.
Yeah, sure.
Thank you, sir. So what are the various risks? Reliability and vulnerability. Reliability of the cloud service provider, vulnerability of the systems that are hosted there. Multi-tenancy, earlier I had to go attack Citibank if I'm a hacker. Now all I have to do is to find out which is the cloud service provider he is using, what are the sessions he is using, and then go register myself as a valid tenant there, if that is allowed. And then I have to just move across, that's all. So all those are highly technical, let us not worry about. Data leakage and data theft. Data leakage can happen despite your protection. Data theft happens when you are not protected sufficiently. And data theft can happen even without your knowledge. That means it's not like losing 100 rupees, right? 100 rupees you lose, you will know. I had 400 rupees, 100 is gone, 300. Data, I had 400 rupees, I still have 400 megabytes of data, right? Now I won't know who has copied what. And single point of failure. All these protection that I give, in fact, today there is a beautiful article in one of the blogs that I read on integrated threat management. Integrated threat management is a great way to manage threats, okay? But the problem is it is also a single point of failure, right? So single point of failure is a big problem. So what you can have is a data redundancy. That means you can have data available somewhere. So even if your original production point fails, you can have your secondary production point. So your business continuity policies, your incident response policies, compliance, external environment, internal environment, cyber attacks, and shadow IT. Shadow IT today is the biggest problem. For want of time, we are not going into it. Shadow IT is people with knowledge of IT but who are not authorized to do it. That is shadow IT in a very small capsule. Because he has an idea about how everything should be set up, he will go ahead and go engage with the session, cloud session, and argue that it is only for the benefit of the organization. But he is not authorized to do it. So shadow IT could be at the top looking like, the open end look like very beneficial to the organization, but at the deep end have all sorts of problems. So a risk assessment normally happens in the, like every assessment starts at identification. Any risk, starts assessment. If you want to assess any risk, all of us know it starts with identification of the risk. Only here, you'll have to have a system characterization sitting on top of the identification and a particular identification from the threat. And therefore, the vulnerability and your control and so on down, right up to control recommendation. That is how a risk assessment happens. And therefore, you identify the risk, you assess the severity, prioritize the risk, implement the risk response, and develop the overall risk assessment requirement. So if you look at cloud risk assessment, it is no different from your non-cloud risk assessment. Except here, the concerned elements are probably very significantly focused on the cloud requirement itself. So therefore, what are the common risks that can happen? Account lockout. Your resources can be hijacked by somebody else. Somebody has already come there, stated he is Sridhar and he has taken over the account. So when the real Sridhar comes, he says, boss, that fellow is already there. What are you doing here? So misconfiguration, the service provider went and misconfigured Citibank and City Union Bank. Loss of control of the account where you lost total control of the account. He has taken over and he has now become you, right? Asymmetric. You and the client and the CSP are not symmetric. There is a problem. Then commingling. Commingling of data is the biggest problem in a multi-tenanted, and multi-tenancy is a basic tenet of cloud. Jurisdictional because of regulatory requirements. And finally, in a crisis, who takes the decision? You or the cloud service provider manager? Who takes the decision? There is a separate story on this, but as Dr. Rakesh has already said, we are already running out of time, so I'll say these are the common risks. Therefore, what does the auditor do? Very quickly, he is not going to look at whether the cloud is to be used or not. He will, but not really from a user perspective. He will look more at how are you using what you said you wanted to use. So what does he do? What are the various data that relates to what you wanted to use? What are the applications, the functions, the process? So he identifies the assets, evaluates the same thing, and looks at the deployment for those assets that you want to deploy, either directly hosted on the cloud or where they are used through that. So what is the model that the service provider is giving, including what are the service offerings, right? And therefore, he will look at the entire data flow. How is it mapped? So the data flow diagrams are very, very important. That is signed off by the service provider. Ingress and egress of data, right? And exposure points, what are the mitigants there, right? And so on and so forth. So what does he do? Once he has this template, he develops which and validates whether the security evaluation is correct, and then applies skepticism. An auditor's job is not to applaud. It is always to be skeptical, right? Why? That is why nobody likes an auditor. If you're worried about, not getting applauses, you are in the wrong profession. Get out of being an auditor. Auditor has to be critical. That is his job. Because performance management will applaud those guys who are doing very well. You got to go find out what he doesn't do well. That is why nobody likes an auditor. So you'll have to bring about the broader context of the organizational objectives. So macro, micro, this I think, Dr. Rakesh, we are sharing this with all the participants, right?
Yeah, we will check.
Yeah. So we have given you some pointers onto where the auditor's perspective can be broken down at the, stage level, and the final audit plan will look at what is the business process you're auditing, and therefore the applications and the functions. Obviously, it is not auditor's opinion. He always tests, evaluates the results for reporting. So basic question is whether the application is authorized to be in the cloud. What is the role of the application or service? Information of the data, what type of data, common data, uncommon data, specific data, right? Then competency of people, whether they are people is your own people or vendor staff. In cloud, you are dealing with vendor's vendor, what is called fourth party management, risk management. Normally we have third party. That means, you, your customer, and a service provider. In cloud, service provider has his own service provider, as we saw. So we are having even a fourth party risk management. Do they have the right skills? How do you know? How do you map it? How do you even define it in your service level agreement? All those things. Therefore, what are the risks that have changed by use of cloud versus your on-prem? So therefore, they look at continuous auditing, right? Security risk assessment, then identity management, then security encryption, particularly on your data, your key management. Key management is very, very important. Therefore, the focus is always on security, monitoring and logging, cloud application security is part of security, overall security, and finally container, the actual service. So if you quickly sum up for want of time, the service user focuses on security, cost, and manageability. The auditor focuses on governance, risk management, and continuous monitoring. So if I have overused the time, I apologize, but I'm still open with Dr. Rakesh permitting for any questions that anybody may have. Thank you for patiently listening to me.
Yeah. Thank you, Mr. Sridhar, for an really insightful presentation. So if we have any questions from participants, they can put it in the chat box, or they can ask directly. They can unmute themselves or ask. I think since we are overshooted the time, maybe we can ask them to send a mail if they have any question.
Absolutely.
So we will reply them back.
Absolutely, sir. No problem at all.
So I think since it is already 6 o'clock, we will close the session here today. And if we have any questions, we will forward it to you by email, and then we can reply them in due course.
Will do,
so
sir.
Thank you, Mr. Sridhar, for an excellent and insightful presentation. And we look forward to more such sessions from you. And maybe we are planning few more sessions from RMAI. And very soon we will be intimating you on our RMAI group and through email also. So thank you all participants for joining today's webinar, and see you soon.
Thank you,
Thank
sir.
you. Thanks a lot, Mr. Sridhar.
Thank you, sir.